All right, we can start and see if anybody else joins along the way. So usually what I do is I just give you a call like, around a minute 20 to just like solve the problem and then I will go over it. So try to take a look at number one. Okay, so for this first problem, we have a pretty difficult mixture problem that someone sent me. So I'm going to start with this first piece. It's 30% silicone, which means it's zero point 0.3 times whatever the mass of that part of the silicone is, or that part of the mixture. That gets combined with 80%, so that's going to be zero point 0.8 of whatever the mass of the rest is. So if the total mass is 50, then the rest is going to be 50 minus x. And then that's going to equal, when we put everything together, that's where we're going to get 50%, which is zero point 0.5 of the total, which is 50. So that's the first part of it, is just setting up the equation. Now it's kind of up to you whether you want to just like solve that straightforward. I think what I would probably do is just instead of having to, okay, hold on, we have someone else joining. Oh, hey, Shania. This is actually the problem that you submitted, so I'm going over that now. Um,
Okay,
so
thank you.
yeah. Um, so this is our setup. So again, now that we have the setup of 30% of the one mass plus 80% of the rest equals 50% of the total. Um, Again, up to you whether you want to just like kind of power through this, or what I'm going to do is instead of taking the time to solve that, I would just put it into Desmos, kind of as is. And then we're going to look for the horizontal line is at 30. Okay, so this is important. The solution to that equation is 30. So I'm going to go back, and we have to be very careful with these problems because very likely the value of our variable may not answer the question. So first of all, it wants the weight of the second piece. So naturally, we plug in 30 here and we get 20. Now, this seems like it should be the answer. The thing that 20 represents, though, is that's the mass of the entire second piece. This just wants the mass of the silicone. So we actually have to multiply by the zero point 0.8. All right. So basically, what we have is this total, it's called an alloy, this total mixture is 30 grams of it was this, and 20 grams of it was this. But of those 20 grams, 80% of it was silicone. So we actually have to take this 20, multiply by the zero point 0.8, and that's where we get 16. So the solution to the equation is 30. Then we get 20 for the piece that is the second piece, but then 80% of that is where the actual answer is. So it's like a super hard question.
Wait, could you explain the setup, please? Because I wasn't here to like hear the setup because that's the part I kept getting wrong.
Oh, okay. Um, yeah, so the setup is basically for a mixture problem like this is the hardest possible like mixture problem they could ask on the SAT. Is like when you're combining two things, it's basically the percent times the mass. So this is the zero point 0.3 is 30% times whatever the mass of that part is. So that's just what I called X. And then that's plus 80%. That's combined with 80% of the other mass. Well, the other mass, instead of introducing a new variable, has to be 50 minus x, because if the total is 50, then if I used up x here, then 50 minus x is going to be what's here. And then when you combine that together, you get 50% of it, 50% of 50.
Um, Okay, sorry, one more question. I was thinking that it would be like 25 times 0.8, but that would be wrong because there's additional, it's silicone plus additional things in the second piece.
Hmm. Yeah. So it's
Yeah.
like 30% of this is silicone plus 80% of this is silicone gives us a total of 25 grams of silicone.
Okay, that makes sense. Thank you.
Yep. Um, wait, I think I didn't hear your question.
How likely is it that we get a question like this on the SAT?
I would honestly say unlikely. I don't see a lot. This is a very specific type of problem, like this mixture problem. And this is like the hardest that it gets. I mean, I don't know, but I would say unlikely. I don't come across a problem like this that often, but it
All right,
certainly comes up.
got it. Thank you.
Hmm. All right, let's try number two. Okay, so a couple things they do here. We should recognize this as y equals mx plus b. So they just kind of the slope is really k. So when they say what is the slope, we're really solving for k. And then they give us this point a b. If they ever give you a point, the first thing I would usually do is just plug it in. So that means this b is really y and this x is really a. All right, so it might seem a little strange at first the way it's set up, but if you just plug this point in and then realize that if they want the slope, they really want k because k is in the same position as m, and then it becomes just a pretty straightforward algebra like rearranging problem. So just add 2 to the other side, and if I want k by itself, just divide by a. So then I have b plus 2 over a, which is just answer choice b.
That makes sense. Thank you.
Good?
I have a question though. For this, I didn't think of plugging it in, but I did like the slope thing. Like I just plugged in 0 for x. Would that still work? And
Yeah.
like extra.
Yeah, you
Okay.
use like the point, like, did you use like the point zero, negative two?
Yeah.
Yeah, that works.
Alright. Thank you.
Yeah, so you kind of do like y2 minus y1 equals over x2 minus x1. And your points are a, b, and zero, negative two, because this is the y-intercept. So yeah, that works.
Okay, thank you.
Yeah, a bunch of different ways to do these problems. Whenever I see a point, it's kind of like a cue. I just like plug it in, and then to me, once you plug it in, it kind of makes it really easy to rearrange it. But yeah, this certainly works as well.
Okay, got it.
All right, any other questions? Okay, let's keep going. Okay, this one is a little bit tricky. So all they're telling you, whoops, my bad. All they're telling you right here is they're giving you the slope in kind of a strange way. So if we remember that slope is rise over run or change in y over change in x, they're just telling you that the slope y increases by 3 when the x decreases by 7, which is just a slope of negative 3/7. So that's the point of that sentence or that phrase, which can be a little tricky. Now, I want to figure out which of these even has a slope of negative 3/7. And to go over that, rather than having to rearrange all of them, what I want to go over is when you have something that's in standard form, I would rather, especially on the SAT, not have to change forms too much and spend a lot of time doing that. So what I usually tell students is to just know that the slope in standard form is negative a over b, but that's simply you don't have to necessarily memorize that. That's because if we were to rearrange to get y by itself, we'd have to move this term to the other side and then divide by this. So if you're able to do that, then it makes checking the slope of these much quicker. because the slope of this one is negative 3 over 7. The slope of this one is negative 7 over 3. This is also negative 3 over 7. And this one's negative 7 over 3. So just doing that quickly can just get rid of two of the answers. And then this last part is I just look at the remaining answers and I make x 0. So when I make this x 0, I'm going to get y is negative, so that works. When I make this x 0, I'm going to get y as a positive. So then that eliminates C, and the answer ends up being A. All right, so we have a slope of negative 3/7, and y is negative when x is 0. So just kind of like using the answers to figure out which one satisfies both of them.
That makes sense. Thank you.
Mhm. Okay. All right, next one. Okay. This one's a little tricky. This one I did just kind of reasoning out using just kind of like making up a sketch of the coordinate plane. So if m times b is less than 0, what that means is that one of them is negative. So either you have m negative and b positive, or you have m positive and b negative. So let's look at both cases. If m is positive, so let's say m is positive and b is negative, then when you multiply them, you're going to get a negative. So that's a positive slope and a negative y-intercept. So that's just something like this. Or you could have m be negative and b be positive, because again, a negative times a positive is going to give you a negative up here. So if the slope is negative, but the y-intercept is positive, that would be maybe, whoops, something like that. So those are your, now those could go through any points, right? But it's saying which cannot contain. So it'll never cross like the negative x-axis. So this point, negative 1, 0, there's no way that no matter what we do, it'll ever go through that point. So like my example could have gone through 0, 1 or 1, 0 or 0, negative 1. Doesn't have to, but it could have. But there's no way to ever have like an opposite sign for slope and y-intercept that'll go through the point negative 1, 0. It's a little harder problem. It's all reasoning.
Could you, sorry, could you please like re-explain slightly? I'm kind of like lost.
Okay. So, yeah. Oops. So the first part of this is to understand that they're saying that the m times b has to be net less than 0, which means m times b has to be negative. So one option is for m to be positive and b to be negative. And what that looks like is if you have a negative y-intercept and a positive slope, this is just an example of what that line could look like. So does that make sense?
Yeah, that makes sense.
Okay. So that line could go through 0, negative 1. That could be down here. And it could also go through 1, 0. Like it's possible to kind of move it so it does go through those points.
Okay.
And then the other option is if m is negative and b is positive, because that again will satisfy a negative times a positive is a negative. So if I have a negative slope and a positive y-intercept, so that means I start up here and I go down. This could go through the point 0, 1, but neither option is ever going to go through the point negative 1, 0. So that's why it says which of the following cannot contain. So there's no way that we could ever go through the point negative 1, 0, which is over here.
Okay, that makes sense. Thank you.
Mhm. All right. All right. Let's try number 5. We actually kind of talked about this earlier. So if you look at the slope formula, that's y2 minus y1 over x2 minus x1. So if we just do that here, the slope is negative 4 over 7. And then y2 is k, y1 is 5. And then down here, x2 is negative 12 minus x1, which is 2. So this is what we're solving. And then that is the first part. I mean, there are other ways to do this, but you've got to be able to like set that up if you're doing it this way. And then honestly, I'm just gonna do it in Desmos. We can easily like cross multiply, but rather than like take the chance of like making any kind of silly mistakes, I would get into the habit of just like setting up an equation to represent a problem and then just going to Desmos. The only difference I'm gonna do is instead of using um, K, I'm just gonna change that to X. So then I'm going to do x minus 5 over negative 12 minus 2. That way I don't have to solve anything, and this does it for me. And then we get positive 13. So then we go back over here. So the answer is 13.
That makes sense. Thank you.
Mhm. All right, let's keep it going. All right, number 6. Right. I went back and forth on a couple different ways of doing this, whether I was gonna like just plug them all into Desmos and see which went through that point. Um, so I think I'm going to go over a way that goes over more concepts. So let me do that first, and then show you maybe the quickest, like strategical way, I guess, to do it as quickly as possible. But what I want to go over the is just the different forms. So if they give you the slope and a point, then what we would want to use is point slope form. I feel like this is the one that students know the least, and it can be useful. So that means we would have y minus 8 fifths equals negative 1 fifth, and then x minus 13. And then what I want to do is these are all in standard form. So to get it in standard form, I'd do this. So if I distribute the negative 1 fifth, I get that. And then what I'm going to do is multiply everything by 5. So I'm going to get 5y minus 8. So multiplying these by 5 just gets rid of the 5. So I'm going to get negative x plus 13. And then finally, standard form, I want all the x's and y's on one side and then the constant on the other. So if I add the x over here, I'll get the x plus 5y. And then if I add the 8 over here is where I'm going to get the 21. So that's where we get the answer A. But I'll admit that's a lot of work to do for a problem. Um, but again, in doing this, I like to go over all the concepts as well because they all can be extremely important. And the more the forms and concepts we know, the better off we'll be. But if I were just trying to be as efficient as possible, what I would have done is what I said earlier was that in standard form, the slope is always negative a over b. And if you look at that here, the only two answers that give you a slope of negative 1 fifth is A and B. So I would have eliminated C and D right away. Um, and then what we could have done is just you go into Desmos and you plot this point, and then you just graph the first line and you see if that goes through that point. And if it doesn't, then the answer is B. So I feel like that's probably a quicker way to get it than this. But again, in doing these like sessions, I like to go over like the math and the concepts as well because they are equally as important. All right, let's keep going. So take a look at 7. Okay, this one I'm actually gonna do the whole thing in Desmos. More so there's a couple things I'd like to go over to make sure the students know how to use Desmos for. So what we have is 2 points. So I'm going to use a Desmos table to just quickly give me the equation. we should know that perpendicular lines have opposite reciprocal slopes, which is going to narrow our answer down to two answer choices. And then we're just going to figure out which one goes through the point 3, -2. So we go to Desmos. What you do is you're going to add a table. So the 2 points they gave us was 2 and then a half, which is zero point 0.5, and then 4, 2. You just hit this regression. Its default is linear, so we're good. And our slope is 0.75. So hopefully we know that 0.75 is 3 over 4. So the line perpendicular to that is going to be the opposite reciprocal. So the slope of the answer has to be -4/3. So that actually is enough. So I'm actually going to get out of Desmos now because then we have a little bit of a shortcut here. So what we just learned in Desmos was that the slope of this line was, hold on, whoops. Let me get the pen here. So we just learned in Desmos, which I think very quickly is that the slope here is 3 over 4. So the slope of the line perpendicular must be -4/3. So that gets rid of these two answers. And then notice that this answer, -2 is the y-intercept. That would be the point 0, -2. Well, a line isn't going to go through 0, -2, and 3, -2. So that one just has to be wrong. So that just leaves us with D. So we didn't even have to plot that into Desmos because the answer choice, again, the better we know the forms, the y-intercept's -2. So it's not going to go through the point 3, -2. This is one, of course, you could just find the slope by hand if you want, but to me, just throwing it into a table can give you the slope more quickly. All right, let's keep it moving. Let's try number 8. This is another one I'm going to use Desmos for a decent amount of it. So if we take a look at the fact that this goes through the origin, um, we really want the slope of this line, but the slope of this line, we don't really need the slope formula. If you can just look at it as you're going like up 8 over 6 because the y coordinate's 8 and the x coordinate's 6. So that's a slope of 4 over 3, which means the perpendicular line is going to have a slope of -3 over 4. And again, if we know a point and we know the slope, then what I'm going to do is I'm going to use Desmos to find the x-intercept. So I'm just going to plot it in point slope form so I don't have to like rearrange anything or solve for anything at all. So point slope form is useful because all I have to do is plug it in. So I have y minus 8 -3/4 times x minus 6. And then that's what I'm going to use Desmos for. So if we go to Desmos, whoops. So now in Desmos, I just put in y minus 8 equals -3/4 times x minus 6. And then I'm just finding the the x-intercept, which is 16.6 repeating. So it depends on how you want to give that answer. So let's look at that. So 16.6 repeating. Let me go back here. So that means what we want to do is 16.67. So not typically, if you're going to use decimal form and round it, then you're going to use 5 characters. So this is why I rounded it this way. So I have the decimal counts as a character. So I have 1, 2, 3, 4, 5 characters. Um, if we do it the other way, which is to take this and if we want the x coordinate of the x-intercept, then we make y 0. This might be a little bit of a longer way of doing it, but I just want you to see this answer too. I would multiply each side by -4/3, and we end up getting 32 over 3 equals x minus 6. And then if you add 6 to both sides, 6 is 18 over 3. So you get 50 thirds. And sure enough, 50 thirds is this answer. So 50 thirds is the fraction answer, but you could use 16.67. The rounded answer would be fine as well. So this is, I don't know if it just depends on how you look at it, but this is the kind of the more like mathematical, like school way to do it. And then just throwing this equation into Desmos is just like probably the faster way to find the x-intercept.
Um, I kind of am a bit confused um on like how you got C from doing this though. Like I get the slope and stuff, but I'm just like kind of confused how you got C from that.
Okay, so do you understand how I got this equation?
Yeah, that's
Okay.
just the slope one.
Yeah, so that's the equation of this line.
Yes.
And what C is where it crosses the x-axis.
Oh, okay, and that's why you just got okay, understand.
Yeah, I wouldn't do both ways. Yeah, where I got the 16.67 was because I graphed this in Desmos and I just literally just like looked for the x-intercept.
Okay, got it. Thank you.
Yeah, it was just showing, I bet another answer to this problem would have been 50 thirds, which we could have got if we got 16 and 2/3, and there's other ways to get that, but um, this would have been the other way of doing it. You make y 0 because this clearly has the coordinates 0, or sorry, this clearly has the coordinates something comma 0.
Okay, understand. Thank you.
Mhm. All right, take a look at 9. Okay, this one doesn't have too much work to do. The idea here is if these lines are parallel, then they have the same slope. So if you look at the slope of this one, it's going to be up 2 over 5. So we have a slope of 2/5. And then this one is going up 4 over a certain amount. So so that means that slope has to equal if I go up 4 and then this would be p. So all we're doing is doubling it. So if I go like up 4, I must go over 10. So if I'm going over 10 to keep the slopes the same, to keep the lines parallel, then this value of p must just actually be 10. Because if I'm going 10 units to the right, it would be 10 comma 0. So the value of p is just 10.
That makes sense. Thank you.
Good. Yeah, that one I've seen several like that they consider, like the College Board considers it a hard problem, but if you're looking at it the right way, it's one that doesn't take very long. Uh, all right, I don't know. The timer's kind of messed up here. All right, it's fine. I'll just give you like a minute, so I'll give you a little bit to try this one. Okay, this is similar to one we did earlier. The way that I would do this, there's two ways. So the first way would be to recognize that this plus 6 is the y-intercept. So this is the point 0 comma 6. And then you're just going to actually find the slope. So it's y2 minus y1, so 6 minus 2. And then x2 minus x1, 0 minus 3. And you're going to get 4 over negative 3, which is negative 4/3. The other way is, like I said before, if you see a point, plug it in. So if I plug in the point, I make y2, I make x3, and then know the value of m is just the slope, or in this case, m, you would subtract 6 and then divide by 3. All right, so either way, negative 4/3. So either plug the point in and solve for m, or realize that the y-intercept is its own point and find the slope using the slope formula.
That makes sense. Thank you.
All right. All right. Just a couple more. All right. So for this one, I'll show you a couple different ways to do it. The first way is just in Desmos. And then within Desmos, there's a couple different things you can do. So if you're given a table like this, you could just use the Desmos table. And since it's a line, we only need 2 points. So I'm just going to use the positive points. You can type in all three if you want, but it can be kind of just wasting time. So I type in those two of the 3 points that were given. I find the equation. All right. So then it's just asking me k of 4. So you can just either plug in 4 here. You can just do it here. You can just do 3 times 4 plus 16, or you might just know that quickly in your head is 28. If the numbers are bigger, another option is to just graph x equals 4. Um, and then you just find the intersection and you see that's 28. So just showing you just like a couple different ways if the problem happens to be a little bit harder. All right, so our answer is 28. So then we go back. So the answer is D. But there's actually a little bit of a shortcut here, which won't always work, but which is why I showed you the Desmos way first. But if they ask us k of 4, well, 4 is just halfway between 1 and 7. So since it's linear, the answer is just going to be whatever number is halfway between 19 and 37. And the number that's halfway between two numbers is the average. So if you just find the average of 19 and 37, that is sure enough 28. So you just do 19 plus 37 divided by 2. So that is if they ask you an input value of a table, sometimes there's a way to just get it kind of immediately without ever knowing the equation of the line. But if not, or you don't remember that, then definitely take advantage of the Desmos table to come up with the equation like really quickly for you. All right, and then last problem. So what I'm going to do is one way to do this is I'm going to just find the slope of this. Um, or you know what? No, I think I'm going to just I'm going to use the points because like, I think I'm just going to use the answers and the table. So I'm going to start with this one, right? Because like the correct answer, when I replace X with 1, the correct answer should give me 3K plus 6. All right. Um, so when I plug 1 into this first answer, I actually get 3K minus 6. So that's wrong. All right. This one, when I plug in 1, I get K plus 2. So I do get 3K plus 6. So that works. This one, when I plug in 1, I obviously get 3K plus 6. And this one, I get negative 3K. I don't get that. So this one is wrong. So what I've done is I've narrowed it down to these two, and now I'm going to go to this. I just stayed away from like plugging in a negative. So now I'm going to plug in 2 for x. So if I plug in 2 for x, let me actually do this one. I get 2k plus 4. And when I distribute that, I do get 6k plus 12. But this one, when I plug in 2, I get 6k plus 6. So now this one is wrong, and the answer is B. So it's kind of going back and forth on different ways to do it. I was trying to avoid having to like do it the long way and like find the full slope in terms of K and all of that. So I think that's probably the easiest way. Maybe there's an easier way. But so you just like check the answers. You plug in one, see which one gives you 3K plus 6. Since two of them do, I have to go to the second point to kind of like break the tie.
This type of question would never be open-ended, right?
No, it can't be. Yeah.
All right. Thank you. That makes sense.
Yeah. This type of you'd have to use your answers. Good point.
Okay. Cool. Thank you.
Yep. Okay. Any other questions? Okay, then we can stop there. So thanks for coming. I'll email out the answer key in the video, and I hopefully will see you next week.
Thank you. Have a nice day.
Thanks, you too.
Thank you, bye.
Bye.